To begin with a few words about the configuration of the frontend application, which will give you a better understanding of the mechanism I used in the components. As I said, on the frontend I use an application written in the Nuxt framework. I also use the built-in H3 server, which means I enjoy the benefits of server-side rendering. In the server files, except for a few endpoints that require dedicated handling, I handle all other requests in a single file, so-called catch-all route, which captures any path that matches this pattern. In other words, this file handles all subpaths of the server API directory. When calling the API, which is served by the previously discussed Django application, I use the proxyRequest function, which allows me to redirect requests to another server. How does it work? In a nutshell, in config, I store the destination API address in a variable visible only on the server side and invisible on the client side. Using the event passed in the request, I retrieve the path and remove the beginning, which is everything that comes before the string /API/ in the URL. In addition, I retrieve the language version set in the cookie so that I can send it later to Django, which will know what language to send the response in. I also retrieve the token of the logged user with a simple function that returns the token stored in the cookie. Nothing extraordinary, I would say. Here we have the standard simple cookie operation. The only difference is that these cookies are not visible on the client side, so JavaScript has no access to any sensitive data like the token or the final API address we call. Let's have a look at the function that saves user token. Although it's not necessary to understand the workings of the components, but I'd like you to have a full picture of how the Django knows what user is logged in. The cookie that stores the token is a HTTP-only cookie, so as I said, it won't be accessible from the browser's JavaScript. Dynamically set secure for production and test environments will provide cookie support only over HTTPS, while in the development environment it will allow the use of HTTP. And the same strict protects against CSRF attacks because the browser will not attach this cookie to requests coming from other domains. Okay, that's it in a nutshell. We don't need to go further into the details of the used safeguard. Let's go further. Having the token and language and location of the logged in user, I can include them in the headers in the request sent to the API. By doing so, I authorize the user and retrieve from the API the data the user is allowed to see. Let's see next file audit.ts, which defines the store we will use. In general, I use store pinia to manage the state in the application. In the file, I define the store which contains the necessary variables and functions we will use. A global error is a reactive variable from error store in which I store possible API errors and which displays them in the application. I will skip the description of API error handling in the application so as not to obscure the whole picture. Let's focus on discussing the presentation of user logs. Logs. Here we will store our logs fetched from the API. The selected log ID will be useful for storing the ID of the clicked object for which we will display details. Selected log data. Here we will store the details of the clicked log after retrieving its details from the API. In the logs data pagination variable, we will store the pagination information of the retrieved logs if the pagination is returned from the API. Here we also have an asynchronous fetch logs function that uses the reactive useFetch function available in Nuxt, which simplifies the fetching of the data from the API and has built-in cache, SSR and error handling. As you can see, we are calling here a dynamically built API address based on root full path. I will come back to this in a moment and discuss it in more detail so you will see how it works. In the fetch log function, we also use useFetch, but here the API URL is slightly different. We call the endpoint API audit and the ID of the selected log, which points to the specific object with the ID sent in the URL. In other words, this API address will be served by the retrieve model mixin that we added in the Django view class. This URL that we pass to the H3 server, as you remember, is converted to an API address where I use the join URL from the UFO package to combine the addresses stored in the API base and with the API address called in the fetchlog function. Okay, let's go back to the audit.ts file. The solution that I have shown here and that I use in the application is convenient and makes it easier to work with the APIs. Especially if we are using one API in the application, although it can be easily solved for several APIs as well. That's why, as you can see, the pages directory more or less reflects the structure of the Django application I have on the backend. This makes it easier for me to figure out the frontend and backend applications, and I have a better structure in my code. Based on my experience with larger applications, maintaining a well-organized file structure becomes crucial. Okay, I think that's enough for now. We will still go back to our store, not once I think. Now we can move on to the next file. The pages audit index.view is the page file in the application where we display user logs. For those who do not use Nuxt, Nuxt builds routing in the application based on this directory. Here we import our store that we have just discussed, from which we retrieve the variable selected log ID. Just like on any other page, I put a page header component at the top of the page, but that's not important. A simple has group function checks the permissions of the logged in user. Only user with owner and manager permissions can view the logs, which is specific to this project, and we don't need to deal with that here. If a user doesn't have the appropriate permissions and by some miracle he gets to this address, in the application he will see the appropriate message about lack of permissions from the no access right component. Okay, these are details specific to this project, not relevant to the presentation of logs, so let's go further. The logs themselves are fetched and displayed in the audit logs component, which we will get to in a moment. The variable selected log ID, if defined, triggers the display of the modal in which we present the log details, and which I will also discuss in a moment. Okay, let's now take a look at the component that handles the display of user logs. isLoading is a variable that I use in this component and whose main task is to display the loader in the cart component. Of course, here we also use the audit store from which we retrieve all necessary variables and functions. Add or update query param is a simple function available globally throughout the application thanks to its placement in the composables directory. I will skip discussing it. This function adds or removes query params to the application's URL using router replace. It's not important how it works. What is important for us is the result of its operation. Okay, after loading the component, we make sure that the logs and paginations are empty, and then using add or update query params, we add the first parameter to the URL with the name page size and the value 25. As you can guess, thanks to this, the API will return logs in sets of 25 records. After adding the parameter, we call the fetchLogs function that we have defined in the audit store. Let's see how it works. As you can see, after accessing the user's logs page, the page size parameter has been added to the URL. As you remember, in the fetchLogs function, we use root full path, which gets us the URL we are on, along with the page size parameter. The root full path is nothing more than the end of the URL, in this case audit, and the page size 25. What's next? We add the string /API at the beginning and pass to use fetch to call the API. API requests are handled in the catch-all file, where after adding the correct Django API address, we use proxyRequest to send the request to the Django. In other words, the URL of the front-end application is the same as the endpoint of the Django backend. That's why, as I said a moment ago, the structure of the pages directory reflects the structure of the application in the Django, more or less. Let's go back to the audit log component. In addition to fetching the logs using fetch logs, here I also define the show details function, which is simple and it does two things. First, it assigns the log ID value to the selected log ID variable we defined in the audit store. Then it calls the fetch log function, which retrieves the log details. Let's take a quick look at the template. The UI card is the component of the whole block where we display the log list. In it, we have the slot header where I put the name and another component with the filters. We will use it in a moment and which I will discuss in more detail. Then the header component of the log table in which I describe the columns names. Nothing special. Below in a loop, I display the individual logs that were returned by the function fetch logs and whose results we saved in the variable logs. Finally, in template footer, that's another slot, I place a pagination component to which I pass the pagination returned from the API stored in the logs data pagination variable. This component displays, as you can see, the links to the specific logs pages. Okay, one more thing that I left out. By clicking on the audit fragments log row, component will call the show details function to which we pass the log ID. This function will retrieve the details of the log, but we will talk about that in a moment. Now let's further discuss the log row component, which shows the row of the log table presented here. In it, we have three props in which we pass the log data to display. IDX, which I use to animate the display of the line, and the full info parameter, with which we define whether to show the full range of information or not. I use this component also in the related logs component, in which I don't show all the information. That's why I added these props. Here we also have a simple function that returns the color of the border depending on the action performed, so that in the user interface we can better show what the log is about. I am wondering why I made a function here to return a color and didn't use a computed, which will work better in this case. Let's rewrite it quickly. Code optimization is never too much. The computed in this case I think will be more efficient than a simple function. Let's move on to the template section. Here I display the table row component, which is not important here. In the first column I add the icon illustrating whether the log is about fetching data or uploading data to the server, and the name of the action performed. A small side note, as you can see, I use Tailwind CSS to style HTML elements. I also use the icons available in Font Awesome, which makes it easier for me to work on the application interface. The second column is the time the log was saved in the database, where I use the day.js library for formatting. In the next one, I show the name of the user who performed the action. Now the description. As you can see, the description is displayed in English. As you remember, in the database, we store the log IDs and not their descriptions. Let's display the network tab of the browser and see what the receives data looks like. When I change the department and send a request to the API, in response, I get the found results in the results key and the pagination object in the pagination key. We will come back to the pagination later. For now, let's see the results. Here we have a list of objects representing user logs. In the description keys, as you can see, we have our ID as we specified in the view on the backend. Let's close the browser console. I will now show how it works on the frontend. If we change the language of the application, the descriptions will also change to the selected language. Now the application log descriptions are in German. Every time we change the language, the descriptions also change. To handle the translations in the applications, I use I18N module to which I pass our log ID stored in the database description field. Thanks to this solution, I can easily control the log descriptions and possibly modify them if I ever decide that a different description would be better for a given identifier. In the translation files, as you can see, I have a number of items for logs for each language of the application. Although it is also possible to store different language versions in the database, there are special Django libraries for this. I decided on this solution for two reasons. First, database stores less information, and the second, adding another language to the application only requires adding a new file in the locales directory. I don't have to override the log records in the database if I add another language in the application. Okay, let's return to log row component. In the next column, I show the called API URL. The address can be long, which could mess up the layout, so here I use the truncate class. To display the whole address, I use the v-tooltip directive. In the last column of the list, I show the name of the executed method and the curly braces icon for requests containing query params, and the database icon if the user has initiated changes to the database. That is for all cases when the method is different from get. Okay, I think that's it as far as the component that presents the log data in the log list is concerned. Now let's move on to the log details, which, as you remember, we call the add-click event of the audit logs component, where we call the show details function. The show details sets the ID value of the clicked log in the reactive variable selected logged in and calls the fetch log function to retrieve the details. Now let's see the log details component. Let's see an example of the details that show up when you click on the logline component. This is the expected results. Nothing magical happens here, a simple action assigned to the add-click event. As you remember, the log detail component I placed in the global component site model, in which we have more space to show additional data. I will not discuss this component here. It is a simple component that displays, as you can see here, a model attached to the right side of the browser window. In the details component, I define two variables, show request data and show query params, with which we handle the showing of div blocks with query params or request data. By clicking the expand button, we expand the block with query params, as you can see in the video. I will come back to this in a moment. In the template, just as in the list at the beginning, it shows basic information about the log. Here I present the same data in a slightly different form, which is understandable. A simple presentation of data, nothing amazing. Below we have optionally shown blocks with query params or request data. Since there can be a lot of data here, I use the view animate height library, which nicely animates the expansions of elements on the page, automatically adjusting the height of the block to the desired size so that the entire content of the block is always displayed. With the expand button, I simply change the state of the show request data or show query params variable from true to false and from false to true. This is an easy to implement solution that is useful for this type of user interface elements. Exactly the same mechanism we have for the block with request data, in which I show the data sent to the database. Information stored in this way allows us to determine who made changes to the database record and when. Okay, let's now discuss the related logs component, in which I show the logs associated with an object. In this component, I define one main function called useRelatedLogs. Although I could simply define the variables related logs pagination is loading, or the function to fetch related logs in script setup, But this solution improves code readability, so I often use it for longer scripts. Here I use selected log data variable defined in audit store and the variables and functions defined in use related logs. Let me highlight it again. This approach is not required, but I use it for my own convenience. If the use related logs function that only the related logs component uses would be too long, I can easily move it to a separate file and in the component retrieve only its variables and functions that it has defined. From a programmer's point of view, this makes things easier, especially when working in development teams where different members of the development team simply use related logs function. They don't even have to think about the operation of different functions they have defined in this container. Okay, let's go back to the code. Fetch related logs, as you can see, calls the endpoint API/audit with the corresponding parameters, content type and object ID, which are stored in selected log data. In addition, I pass here a page size parameter equal to 5 and a page parameter, which I will return into in a moment. I store the returned logs and pagination in the variables related logs and related logs pagination. Then I use these variables in template to present a list of related logs. Here I use the already discussed log row component, but without the full info parameter, so that log row will show only the information relevant to this component. We use the add-click event of the fetch log button to retrieve related logs. I don't call them immediately after entering the log details because the user may not always want to see them. By clicking the button, the function will be called and this function, after retrieving the data, will store results in related logs, after which template will display the found records. A standard solution already discussed in previous components. The data here is simplified, but of course the translation also works just like for the list. This is the same component as in the list, so it would be strange if here the translations for description wouldn't work. Okay, let's now move on to the log filtering and search component. In this component, I use a global variable department select, which contains a list of departments defined in the component. It is a simple list with departments. We do not need to discuss it. I use it to build a department select. Here we also use the already known fetch logs and add or update query param functions. In the use audit filters function, I define the variables and functions needed to maintain this component. First of all, the variables filtered department and search phrase, in which we store the values selected in the select or user search field. The filter department function simply sets the department parameter to the value selected in the select and calls the fetch logs function. Simple. All the work is done for us by fetch logs, which we call in various components, and that is why I defined it in audit store. We can call the function defined this way in any component, and its results will affect the whole application, not just one particular component. Okay, let's move on. The action of clear department is already known and is also simple. We clear the value for the filter department variable and call the function that retrieves the data. The form select component, which I don't discuss in detail because it's not important here, emits two events that I use here. The add change called when the select value is changed will call the filter department function, which, as you can see, is reflected in the URL where the department parameter with the department ID has been added. As a reminder, one more reminder, fetch logs uses root full path, meaning that the department added to the URL parameters will be sent to the API to filter the results by that value. The full path contains the page size parameter, which remains unchanged, and the ID of the department. Used on the backend Django filters will do the rest of the work for us by returning the right results. Let's go back to the filters. As you can see, changing the department filters the data and the user sees those logs that he wanted to filter. By clicking the X sign, that will trigger the @remove event, which will trigger the clear department function. As you can see, this solution is very simple and easy to use in other components when filtering results for other endpoints. The add or update query param works in such a way that if you pass it a parameter name and a value which is empty, undefined, the parameter will be removed from the URL. If it's not empty, then it will add it. Generally, it's a very simple function. Okay, let's move on to the log search engine for a specific employee. Here we have a bit more interesting solution. The search engine, as you can see, works in such a way that when you type in an employee's name or a part of an employee's name, a request is sent to the API which returns the appropriate results. This happens automatically, and as with the other parameters here, we simply add a search parameter with the phrase entered in the input text, and the fetch logs function sends this to the API. Django, on the other hand, knows what to do with this thanks to the proper configuration of the Django REST framework, which we discussed in the previous backend part of the video. The search action is triggered on even key up, that is every time someone presses a key on the keyboard. However, I applied one additional protection here. The search results function, similarly to filter department, first adds a parameter to the URL. Then, however, it does not immediately call fetch logs, but refers to the get logs debounced. I use here Lodash library. This code debounces a function called using Lodash debounce method, ensuring that fetch logs is executed at most once every 300 milliseconds, even if called up multiple times. I'm using this for two main reasons. First, this prevents excessive API calls, avoid calling fetch logs on every input change. And this also improves performance, ensures smooth user experience with minimal lag. Clear search works similarly to clear department, and we already know how it works. We can move on. And finally, briefly about the pagination component. As you can see, in the default version, it works the same as for filters by adding the page parameter in the URL. By clicking on the individual pages or arrows of the previous and the next page, we operate this parameter by setting its correct value. Having this parameter in the URL, it is enough to send it to the API, and there the Django will already correctly handle it. The pagination component itself takes a pagination object returned from the backend as a property. And in the pagination clicked event, we define the function that will be executed when the buttons in this component are clicked. Nothing extraordinary here. Someday, perhaps when discussing pagination in Django, I will come back to this component and describe it in more detail so that you can use this concept in your projects. That's all for now. If you liked this video, I would appreciate it if you like it. If you think that the information presented here may be useful to your friends, I encourage you to share it. If you would like to contact me, please write to my email address presented here. And if you would like me to discuss any issue in more detail regarding Django or Nuxt, let me know. I will see what I can do. Good luck with your projects and have a great day.